Hello everyone, my name is Shuyang Chen. I am a third-year PhD student in Department of Mechanical Engineering at RPI. My research focuses on robotics and control. RPI is located in Troy, which is a small but peaceful town. The campus is very beautiful, especially in summer and fall. I work at the MIC Robotics Lab, and here we have access to multiple robot platforms, including the ABB robot, the Baxter robot, the Multiman robot, the UR robot on the left, and the Sawyer robot on the right. My research focuses on robotics control. The first project I will show you here is the development of a safe teleoperation controller, which can achieve collision-free robotic teleoperation for panel transportation in a simulated test bed. The red arrow denotes the user-commanded velocity, whereas the gray arrow denotes the safe velocity computed by the controller. As you can see here, when the panel is close to the wall, the safe velocity will drag the panel away from the wall to avoid any collision. And when the panel is far from the wall and there is no risk of any collision, the safe velocity will be the same as user-commanded velocity. I also work on industrial robot trajectory tracking control using deep learning techniques. As an example, for this project, we combine iterative learning control, deep learning, and transfer learning for tracking control of an industrial ABB robot. Specifically, we use neural networks as a feed-forward compensator for robot internal dynamics. And we implement gradient descent iterative learning control in a simulation environment, Robot Studio, to collect training data for the neural network training. We first test the training network in Robot Studio for tracking a 6-dimensional sinusoidal joint trajectory. From the plot, you can see the network works well in compensating for the robot internal dynamics. We then apply the transfer learning to overcome the reality gap between the simulation and the physical robot, so that the fine-tuned network works well for physical robot trajectory tracking control. The last project is robot-assisted deep rolling, which is a mechanical surface treatment method in which the workpiece surface is exposed to high local mechanical load. Essentially, it is a hybrid force and motion control task, and we want to track both desired force and motion profiles accurately. This video shows the process of applying 1000 Newton force to a sample along a sinusoidal motion trajectory. We developed a controller based on iterative learning control and a generalized damper, which can greatly improve the force tracking performance. Here it shows the result without any iteration. Here it shows the tracking result after 7 iterations. From the table, we can see the force tracking accuracy improves with the number of iterations. We can see the motion tracking also improves.